Hey there peeps, welcome to Plotly, Plot.ly. This is a web app that's going to help us plot our data for science labs that we do, in this case battery of buggies. So here we've got the chart. So it says click to enter plot title. We're going to call it battery of buggies. That's the title of our lab. Here we're going to click to enter x-axis title. We want time information to be represented here, and the unit in parentheses will be seconds, so it's parentheses s. On the y-axis, we're going to use distance, because that was the other thing that we measured. So it's distance, parentheses, meters, like this. Pal, it actually automatically puts it up as vertical. So we're done with our labeling here for our chart. Now we can start formatting the spreadsheet piece for data. You'll recognize that this looks a lot like Microsoft Excel if you've ever used it. If not, well, this is going to be an experience that'll be very useful. These are great skills to have, not only for science, but for any endeavor in life. All right, you're going to be using stuff like this in science, statistics, or who knows? There's so many different things that this is useful for. Accounting, whatever. All right, business, yeah. Anyway, what I've done is I've squished this column over here just to kind of keep it as a placeholder. And we want to rename B to something more meaningful. Okay, so this would be distance car 1, like it looks like in our lab sheet. And I'm going to put it in parentheses meters just so that we remember what the unit is, because it's very important. Confirm. I'm going to widen that out. So I'm going to click drag in between the two column headers here, and now we can read it all. For C, we're going to rename it something more meaningful. This is time car 1 in seconds. Confirm. We'll widen that too so we can see it. Excellent. We'll squish the D so that we can just use it as a placeholder between the two sets of data. I'm going to only do 2 sets of data for demonstration. We know you've got 3. That's cool. So rename header, and this is distance car 2 parentheses m for meters. Confirm. And widen. Good. F. All right. Rename header. Time car 2 parentheses s. Confirm. And I'm going to widen it, and now we can see that header too. Now I'm going to put the data in there. When I did this lab, I made it simple so that the car went 1 meter, 2 meters, 3 meter, 4 meter, and then 5 meters. The time for car 1 was 2.11 seconds, followed by 4.04 seconds, followed by 6.01 seconds, followed by 7.98 seconds, and 9.91 seconds. There's the data. All right, so car 2, distance for car 2 was, again, the same as before. 1, 2, 3, 4, 5. Excellent. Time for car 2 was 1.05 seconds, 2.03 seconds, then 2.95 seconds, 4.09 seconds, 5.04 seconds. Okay, good. Now what I'm going to do is raise this up a little bit so that we could just kind of see everything here. We can see both our data for the 2 cars, and we can start seeing the chart here. Now, over on the left here, you'll see it says chart type. Scatter plot's the one we want. We can choose between a bunch of them. We don't want line plot. We don't want bar chart. Scatter plot is the one that it is. Okay? So we need to then choose our variables that will fit the x and y axis. So for x, we want to choose time car 1. Done. And for y, we want to choose distance car 1. And there we go. There we have it. You see the dots that are here, and they represent that plot, which is excellent. All right. We'll add a second trace, which is another line over here that we'll do for the other car. And in this case, in orange, we want to select something different. We actually want x-axis time car 2, and we want distance car 2. All right. You can see that both the plots are here. They're represented here like this. Okay. I can also do this. I can do something called auto scale. So I'll click that. So it looks like we're doing good over here. But once we see the 4 points here, and that looks pretty good. We can also zoom in and out like this so we can see the plot over here. Something's a little screwy. Hey, did you know what? I typed the wrong number. That's bad. This is called an outlier. 20.3 seconds? No way did it take 23.3 seconds. So 2.03. So I can recognize right away that my data was screwed up because this was way over here. So good to know. Now, oh, that looks so much better. All right, we'll go back to auto scale, which is this guy, and looks excellent. All right, so now we have our plots. And what we're going to do is go to analysis, plus for the analysis, and we'll click the bottom one here. It says curve fitting, and we're going to choose the chart type. Well, we want distance car1 first, and linear run. Okay, we're going to click this on here as well. And this information looks complex, but I'm going to tell you exactly what it means in just a moment. But let's do the same thing for car2. Let's hit plus analysis, curve fitting, and we're going to go and choose, let's see, we wanted to choose the next one, car2. Let's see, where to go? That's car1. All right, I think, all right. Do that again. Yep. Here we go. Ah, the chart type. I was just, forgot that part. Okay, here we go. So we're going to hit run for this, for linear. That's exactly what we want because this looks like a line. We've got it. This is excellent. Let's click this over here. All right. So here's what we have. We've got two lines. The blue line was for car1. The orange line is for car2. Notice that car2 has a steeper line on this distance versus time graph. That means this car was going faster. When you have a steeper line, a steeper slope, that means the car is moving faster. When you have a more gradual slope, that means the car is moving slower. How fast was the car moving? You might want to ask. What's the average velocity? What's the average speed? We'll look over here. This number, ooh, that's funky. Let's get rid of that. Hello. Back. That's not going away. There. Good. This is where it says 0.5118. We're going to round that to 0.51. That's the speed in meters per second. That's the speed or velocity of car 1. So what we're reading here is actually the steepness of the slope, and 0.51 is the steepness. This is an average value for the data here. You're going to do the same thing for your data as well, and you're going to read this, and that's going to be the average velocity for your car. All right. In this case over here, it's 0.995, so it's almost twice as fast. Not quite, but so that's what this indicates over here. This 0.995 means that it is moving at almost 1 meter per second, this car over here. So what you can see is you can get a direct comparison of the speeds by looking at the slopes and how steep they are. And so what we're going to do is we're going to screen capture this guy over here, including the data, and you're going to include that in a quick document that you're going to upload to Schoology and submit as the second part of your lab. So you've got your data, and then what we're going to do is we're going to answer some questions about it thereafter. But that's your mini tutorial on how to use Plotly, and so I can't wait to see all of your plots. I'm sure they're going to look something like this, maybe a little more jumbled, but they should kind of look something along this line. All right, that's what it is. More ad, out.